Here we will investigate the definition of a hyperbola. So this is a GeoGebra applet. You can play with it even yourself if you go to that link on the notes page. The definition of a hyperbola depends on two focal points, again, like an ellipse. So you can see them here in this diagram, F1, F2. And like an ellipse, the hyperbola is defined based on some distances to the focal points. So the distances, though, in an ellipse, we were saying any point on an ellipse would be set so that the total distance to each the focal point is as a sum equal. But in the hyperbola case, it actually is defined by the difference of those distances. So the distance from this point up here, it's called P, to F1 minus the distance from P to F2 is set this hyperbola to be 1.11. So the numbers you see here are exactly the lengths that you would measure if you measured this blue and this yellow line as the distances and then subtract them to find out the difference. And that's 1.1. And that should be true, the 1.1 should be true no matter where we are on the hyperbola. So I'll show you. I'm going to move point P to a different location. So I'm going to do that down here. I'm going to slide it along. Now you can see the name of P. So now I'm just going to stop right about there, just so we can look. So notice now the distance is shorter to the focus here, and it's shorter there, but the difference is still 1.11, right? And even as I'm coming up the other side, notice that there's symmetry. So even on this side, point Q has that same property. It's on the hyperbola, so this distance minus that distance is the same number. It's 1.11. Now the neat thing too is that that 1.11 constant is actually also the length between the vertices. So that is this little width right here. So now I'm going to slide N some more, just because partly it's neat, right? So you can see that that number right here is not changing at all. But the numbers I use to get it are, but they're always 1.11 apart. What happens if I keep going? Oh. Now I'm going to keep sliding N. I lost N. Where'd it go? Oh, now it jumped to the other side. So there's a section in the graph where there is no hyperbola. But I want you to look at what happens as I go outward. So it's still staying 1.11. So that's not really interesting anymore, maybe. But let's just watch and think about the distances. So as I head out, so now the lengths are getting longer, but the distance is still 1.1. So as I head out, eventually they're going to be very, they're both going to be really long. It kind of reset me. But as I head outward, those lengths are going to be so close. They're still going to be 1 point, well, and now it changed my hyperbola a little bit because I bumped it, but that constant is still the same. So, but those lengths are going to be both really long. And so the point as I go outward isn't really going to change its path much. And in fact, the graph will approach a slanted line. So one thing about a hyperbola is that it has asymptotes that are these diagonal stretches along the hyperbola through the center right here. Okay, so I'm just going to stop there. You can play around more if you want. And we'll try some examples.